Okay, today we're going to learn how to solve radical equations, which is actually not too awful bad. Radical equations are equations where it's an equation, so something equals something else. And there's a variable in the radicand. So here's an example of one. And I guess I should show you this. Like I said, I'm not huge on the steps, but we're going to isolate the radical because the way we can think about it, the square root has to be what, or the cube root, or the whatever. And then we're going to raise each side of the equation to the same exponent to eliminate the radical. We're going to talk about exactly what that is in just a second, and then we're going to check our answers. Okay, so right here, 2 times this principal square root equals 4. Well, the first thing I would do is divide both sides by 2. That way we're isolating the radical. And then you can just think about it. Okay, can the principal square root of something equal 2? Heck yeah. What would it have to be? Well, it'd have to be a 4 under there for that to be true. So we're saying that x plus 1 has to be 4, right? Because whatever's under that radical would have to be 4. Remember, it's principal square root, so we're not worried about getting 2 answers out. It's just the main positive one. But what they're saying up here in step 2 is you raise each side of the equation to the same exponent. That will eliminate the radical, okay? So what they're saying is right here, let's square both sides, which is what I did, just thinking about it in a more logical kind of way, like what had to happen. You'll very seldomly see me write down that whole let's square both sides, just because it sort of gives me the willies a little. It's just, if 2 things are equal, like if 4 equals 4, then their squares should be equal. That's why we're able to do this, okay? And then if I subtract 1 from both sides, I'm going to get x is 3. Let's double check, make sure this actually worked. Is that 4? It sure is. X is 3. Okay. Next one, now this one's got a cube root in it. So still, it's easier to think about if you isolate the radical. So if we get this cube root over here by itself, and then I'm saying, what do I take the cube root of to get 3? Well, it'd have to be a 27. So what's got to be under there? That 2x minus 9 has to equal 27. But what I could think of also is let's cube both sides, because if 2 things are equal, their cubes should be equal. And I cubed it because I want to get rid of a cube root. And 3 cubed is 27. So if I subtract 9 from add 9 to both sides, divide both sides by 2, x will be 18. Now let's see if that's true. Is the cube root of twice 18 minus 9 with 1 subtracted from it, is it 2? 36 minus 9 is what, 27? Cube root's 3. It sure is. X is 18. Okay. All right. So this one, the cube root of x, subtract 9 from both sides. All right. Is that possible? Can I take a cube root of something and get negative 3? Heck yeah. If whatever's under there is negative 27. Let's see if it's 6. It sure is. Okay. But also on that step right there, just think about, how do I get rid of that cube root? I cube it. So if 2 things equal, which they says they do, then their cubes should also be equal. All right, now this one we've got a word problem. So in a hurricane, the mean sustained wind velocity, which we'll call V, in meters per second, can be modeled by V of P is 6.3 times the square root of 1,013 minus P, where P is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of the hurricane. So we're trying to figure out what P is. That's what we're looking for. When the mean standard wind velocity is 54.5 meters per second. Okay, so let's take our equation and plug in 54.5 for the velocity. Okay, so this one definitely getting the calculator out. Okay, 54.5 divided by that 6.3. Divide both sides by, hang on, I punched in the wrong thing. I did it again. I'm not really sure how I did that. 6.3. I kept hitting the negative side. So this is about 8.65. All right, now the thing about this, I'm about to square both sides, which if I square the right side, it'll be just 1,013 minus p. I'm going to square the left side. Notice how I put the approximately. I've still got that big long. It was 8.650793651. That's all it'll fill my calculator screen. I'm going to square it, and it's going to be about 74.836. Okay, but I'm like, I squared that big long decimal that was on the calculator. I'm keeping this big long decimal, 74.83623079. And then that means the opposite of P, let's subtract 1,013 from that. One seven or so, which if the opposite P is that, then regular P is about 938.17. So estimate the air pressure. We'll say it's about 938 millibars of air pressure. Okay, so didn't get an exact answer, but an exact answer here wouldn't be as helpful as this approximate answer. All right, now here's where it gets tricky, and here's why step 3 is so important. Like, we've been checking, and you're like, why is she checking it? It's obviously going to work. Well, it doesn't always work. Like, what if you get this? Let's just take an easy one. The principal square root of some number is -4. Well, the solution to that is the empty set. There are no real numbers where when I square root them, I get -4. Not a principal square root, okay? However, if I were to square both sides, I don't like a square, does it? It looks like there is, but the principal square root of 16 is +4, not -4. So, because of this, we have to make sure that we always check our answers, because sometimes algebraically you will do things to this problem and it won't actually still be true. Okay, so here we go. I've isolated the radical. I'm going to square both sides. Now, over here on the right side, squaring it's easy. Over here on the left, I think it's helpful to actually write out that you're squaring it. Okay, so that's x squared plus 2x plus 1. And then anytime you have squares, it's way more helpful to get everything on one side set equal to 0. Let's factor if it'll factor. This one will. So x is either 7 or -2. Let's see. If I put a 7 in here, you always go back to the original problem. 7 plus 1, is that 7 times 7 plus 15 principal square root of that sum? Okay, so let's see. This will be the square root of 49 plus 15. That's the square root of 64. Principal square root of 64 is 8. Okay, so 7 works. If I put -2 in there, all right, I'm going to speed this up. A principal square root cannot equal -1. So I'm going to throw that out and say x is 7, which what we do is the solutions that show up algebraically that aren't actually solutions, we call those extraneous roots or extraneous solutions. Extraneous, like they're just the extras. Okay. For example, 6, we're doing the same thing. Let's square both sides because that radical's isolated. Let's see what we can do with this. Multiplies to be 16, adds to be -10. That's a -8 and a -2. So same deal. X could possibly be 8 or 2. Let's check it. If we put an 8 in, that's true. If you put a 2 in, all right, I can save myself some time. A principal square root cannot equal -2. So x is going to be 8. Okay. All right, this one, let's square both sides. So if it's going to work, x is 2. Let's see if it's true. Is the principal square root of 9 equal to the principal square root of 9? It sure is. X is 2 words just fine. All right, this one, let's isolate, oops, the radicals on a side as much as we can. And then if I square both sides, which again, kind of, I'm not the biggest fan of doing that, but I know a lot of people like it. So X is 2 if it's going to work. Let's see if it does. Let's see if that's 0. 6. So that's the principal square root of 8 minus 2 root 2. Well, the principal square root of 8 is 2 root 2. It does work. X is 2. Okay. All right, this one. Oh, now this is tricky because you can't isolate both radicals. So what if we just square both sides right here? So what we're doing is that. Okay, so if we multiply that, that's just going to be an x plus 2. I'm going to get one of those and one more of them. I'm going to have 2 of these squared x, principal squared x plus 2's plus 1. All right, so over here we've got an x plus 3 plus this. Okay. Ooh, if I subtract 3 from both sides, that's just gone. And then if I subtract x from both sides, ooh, I could divide both sides by 2 if I wanted to. And then I could square both sides again. Which will get me x squared minus x minus 2 is 0. So algebraically, x is either 2 or negative 1. Let's see if they work. Let's put the 2 in. Principal square root of 4 is 2 plus 1. I get 3 over here. I get 1 over there. That didn't work. So we throw out the 2. If I put the negative 1 in, okay, so principal square root of 1 plus 1. 1 plus 1, that's 2. That's 2. So x can only be negative 1.